3.5. Describe how the positron emission tomography PET technique is used for diagnosis, or referred to as a PET scan. So I'm going to use fluorine 18 as an example in this. So anytime I mention 18F, it is fluorine 18. So in a positron emission tomography or PET scan, a radioisotope, which we mentioned in 3.1, will emit positrons, is fed into the body. A common radiopharmaceutical that is used is fluorine 18 or 18F, as it is incorporated into fluoride dioxide glucose, which closely resembles glucose and is readily absorbed by the brain and other tissues. The more active the brain or particular body tissue, the more readily the fluoride dioxide glucose is absorbed by the body. So if 18F then decays, emitted positrons, which will then interact with electrons, annihilate and then produce two gamma rays that are emitted and then picked up by the detectors. I've mentioned that technique in 3.4. PET scans use short-lived radioisotopes with half-lives in order of minutes and hours, and I mentioned that also previously. So we're looking at having an adequate time frame to synthesize these radioisotopes, to get them to the hospitals, and also to have that half-life available for the scan. So because of the short half-life, the radioisotopes need to be produced in close proximity to the hospital. Okay? So these are produced by particle accelerators or cyclotrons. The PET scan machine itself consists of a gantry similar to a CAT scan and a platform on which the patient lies. The ring has a series of detectors that are crystals of sodium iodide that convert the gamma rays into light. Whenever a positron-electron pair annihilates, two gamma rays equal but opposite are emitted. Two detectors at 180 degrees to each other will pick up the gamma rays, with the times that they arrive at the detectors being dependent on their position within the ring. The computers use the difference in time to calculate the specific location that is the source of these gamma rays. Further computation enables an image to be formed showing sections and slices through the body. So as well as detecting where the gamma rays come from, a PET scan detects the number of rays being emitted. This is translated into an image as grey and white, white being the number of gamma rays. Differences in greys and whites of the organ enable us to discuss the function of the organ or the tissue being examined. So, a PET scan, what is its advantage over a CAT or even MRI? It enables the function of organs such as brain, kidneys, or the thyroid to be mapped and investigated. The anatomical information provided by a PET scan is limited. However, PET scans are increasingly read alongside either CAT or MRI scans, so the combination gives us both anatomical and metabolic information.